Save. Okay, recording is in progress according to WebEx. So let's see if it works. You're welcome. So I have selected for you, yes, you can close, back. I think I have selected 4 principles of design for you. Because 7 is a little bit too much to my taste, and some of these principles of design overlap each other a little bit. I have selected 4 that are very relevant for data visualization, and then after each of the principles of design, I will show you some data visualizations that apply these principles. So one of the first, why don't you just go away? There's something here on top of my screen which is blocking my view a little bit. Okay, it's gone. Online teaching, always a challenge. So a first principle of design, which is probably quite obvious, but I think very interesting, is balance. We as humans, we are immediately drawn to things which are in balance, things which are symmetrical. For example, people will be more attractive, or we will think that people are more attractive the more symmetrical their face is, for example. People with a very symmetrical face will be perceived as very, very beautiful. So that immediately shows that something in our brain is really attracted to symmetry and to a balance between things. And on the right side, we have an asymmetrical balance, so there's a disbalance, and it also that catches our attention because our brain is very good at seeing that things are out of balance. So both of these things have their value and can be used in data visualization, both a very balanced and symmetrical way of view that is something that our brain will like, but also asymmetrical balance is something that we can use in data visualization. That is something that our brain will quickly pick up and will quickly get our attention. That's, for example, what we saw in the visual with the sinking boats. There was one boat which was so much larger than the other ones that it created an asymmetrical balance, an imbalance in the visual, and then our brain immediately is drawn to that largest boat because of the lack of balance. As an example, come on, PowerPoint, don't let me down. This is an example. It's in Dutch, but there's only little text. But this is a visual which I made for Statistics Flanders, showing the difference between men and women participating in some kind of sport. So the fraction of men and the fraction of women participating in sports, and how it has evolved over the years, and especially how it has grown over the years between 2009 and 2018 in this case. And by putting these data, men on one side and women on the other side, we achieve some kind of balance in the design, which ensures that there is some aesthetically pleasing component to this design, and that people, well, hopefully will like it or will like to look at data visualizations like this, because there's some kind of balance in the design. You can, on the other hand, also, if you want to play out a disbalance in the design or a disbalance in the data, for example, here, again, it's in Dutch, my apologies, but here, this is a visualization of survey results. And people were asked to tell a story. In this case, it's not really important, but they were asked to tell a story about eating a vegetarian meal versus eating meat. And they were asked to tell a story about this and then ask some questions. And here are the results for the answers to the question. This story made me feel, and on the left side, we have this story gave me energy. Geef me energie, gave me energy. And on the right, we have this story discouraged me, or ontmoedigt me, so it didn't give me energy. And here you see that nearly 2/3 of the respondents, they answered that this story that they just told, that it really gave them energy. So there's a really big disbalance in the data, because 2/3 of the respondents are really on the left side of the scale for this for the answer on these questions, and only 1/3 of the respondents is spread out over the middle and over the right side of the responses. So there's a bit disbalance in the data, and we can exploit that by also introducing this disbalance in creating the visual. So by choosing this kind of data visual where this disbalance is very obvious, it helps in immediately wiring our brains and wiring the brains or priming the brains of the people who are viewing this data visual to this disbalance in the data. And it helps a little bit, this cheating a little bit, but by also putting a small illustration on the left side, and by also putting the title on the left side, we even enhance this balance in the data, and we try to visualize this balance in the visual itself. So the first principle of balance and disbalance is something that you can use both balance or both disbalance in creating a data visual, depending on what you want to achieve. Second principle of design is scale or proportion. I think this is even more straightforward than balance or disbalance. Here we're looking at different sizes will immediately, we will automatically link this with different values in the data. So a larger size compares to a larger values to something more important, and a smaller size correlates to something which is less important. It's very, very basic, but it's a principle which is deeply wired into our brains and which we can exploit if we are creating data visualizations. Technically, there's a distinction between what's proportion and what's scale, but for me, honestly, I don't really see the difference between it. But scale especially actually scale and proportion both is comparing sizes of different things to each other. And I have found one of my favorite examples. I have a lot of favorite examples of data visualization story, but I have found one of my favorite examples here, which is really exploiting again this sense of scale. So we are naturally trying to compare sizes of different things with each other. And this, for example, is a data visualization. It's part of a longer online story in the New York Times about rich families in the United States sponsoring the elections. So families are paying money to the presidential candidates for running their campaign. And this is data visualization showing that actually the majority of this money that's going into these presidential campaigns is actually coming from very few, very rich families. And they did it by creating a data visualization with Monopoly pieces. So I suppose everyone knows the game Monopoly, and you have these green little houses and you have these red little hotels. And what they did is they created a visual. Of course, it's created digitally, but they visualized how a heap of 120 million Monopoly pieces would look like. So there are 120 million households in the United States. So imagine that for every household, you have a green Monopoly house, and you put it all on one heap. Then this heap would be this big almost if it's compared to the White House, for example. And then we zoom in later in the story, we zoom in on the top of this heap, and these are the 158 families which have provided nearly half of the money for these presidential election campaigns. And these very rich families which are sponsoring the election campaigns are shown as red Monopoly small hotels. So comparing these two, the scale of these two different things, so the heap of all the different households in the United States given in green, and then this very small fraction given in red, this gives us, or this helps us to see the scale of what's actually going on. And that's why I like this. And this was for me a nice example of how scale can be used in a data visualization. But in most cases, of course, scale is used in a much more basic way. For example, in a bar chart where you're going to combine the sizes of different bars with each other. That's also an application of scale in data visualization. A third principle of design is emphasis. If we have many things that are very similar and we change one thing, we change, for example, the color of one thing or the position of one thing or the shape of one thing, or the size of just one thing when all the other sizes are the same, then we create automatically, we put an emphasis on this one thing which is different. Again, because our brains are so very good at spotting this kind of things and especially differences, for example. So look at these three examples. Immediately our brain is drawn to the pink one, which is different from all the rest. This is very useful, of course, if we're creating data visualizations. We want to tell a story, and usually we want to draw the attention to an outlier, for example, or to a data point that's interesting for the reader and that we want to put some emphasis on. This is, for example, a data visual which I created based on data for insurance prices in the United States. So not very interesting, but it shows the concept of creating a focal point by putting emphasis on one thing. So for each of the states here in the United States, there are two bars. There's the minimum value of the insurance, or excuse me, the price you pay on average for a minimum coverage insurance, and the price you pay on average for a full coverage insurance. And in many states, this is very similar to each other, and that's also indicated by painting them all in green. And I tried to put some emphasis on the two outliers, the smallest one in Maine, by giving it a blue color rather than a green color, and by also adding a little textual annotation with it. And the same for Michigan, which is an outlier on the other side. I gave it a red color compared to the green color for all the rest. Also gave it a little textual annotation. And just by doing these two things, by changing the color, it immediately draws our attention to these two states, the minimum and the maximum. So that's an obvious, but I think a good example of how emphasis works in a data visualization. And then so the fourth principle of design, there are more principles of design around, but the fourth one that I think is really relevant for data visualization is hierarchy. If we, for example, write a text and everything is in the same font and in the same color and in the same line height, etc., with the same background, then there's not really a hierarchy like you can see here on the left side. Then just everything looks more or less the same, and we don't know what's more important or what's less important. And if we have a hierarchy, so if we make our title bigger and bolder, if we give our subtitles a different color, if we put some columns, some text in columns and some not, then we immediately get a better sense of what's important and what's less important. So it's a little bit similar to emphasis, because we are starting from things which are all the same, and then we are changing a few aspects to draw the attention to it. But in emphasis, we are changing just one thing, and in hierarchy, we are changing different aspects, different parameters of parts of the text or parts of the visual, and in a way to make it clear which parts are more important, which parts are less important, which parts are maybe a sub-part of other parts, things like that. So by making a title, you can make a title very big, very bold. You can make a title a little bit bold and italic, and then you can see that it's also a title, but maybe it's less important than the biggest title. Then you start creating a hierarchy in your design. This is very obvious in layout and in textual layouts. And if you're writing an article, for example, or creating a poster, you can also do it in data visuals. Or for example, this is a little bit more than just a data visual. This is more going towards an infographic, but it would apply as well. For example, if you're creating a scientific poster, this works very well if you want to give one data visual or one key visual about your research or about your results. If you want to give it the front stage, then you put it in the middle, you make it bigger and bolder than the other ones. You give it maybe more color or an accent color compared to the other stuff. And then you get this focal point in the middle where the attention will be drawn to. People will look at this first in the middle, and then if they have more time or if they want to learn more, they can look at the details which are positioned around it. But our brain immediately knows that, okay, what's there big and bold in the middle will be the most important things, and the other things if I don't have time or not interested to read it, that's not too bad, because I can see subconsciously that these are less important. Um, and then we can, it goes back to what we saw in the group exercise, that works well in the data visual is if we immediately get a sense of the main message, and then the side messages are left to the interested reader only, or the reader who has enough time. So for me, four basic design principles, which are immediately relevant for data visualization, are balance or imbalance, scale, to compare different things with each other, or to compare things that we don't yet know to things that we already know, emphasis, by changing just one thing about an otherwise very similar things, we can draw the attention to it. And finally, hierarchy, by changing a few parameters or a few aspects of different parts of the visual or of different parts of the layout, we can show the reader what's most important, what's less important. Those are the design principles. Before wrapping up about design principles, this is one of the most famous designers alive, I think. He's Dieter Rams. There's a great documentary about him. I don't know if you can find it anywhere, but I had the chance once to see it, and it's really great. He's a designer. He has been the lead designer for Braun in Germany for many decades, and he has designed, yeah, as you can see, very minimalist. Sorry, I can't speak anymore. Very minimalistic, but very elegant and very functional designs. For example, for radios, but also for calculators, for vinyl LP players, radios, things like that. So just the basic functionalities. It's very little details and very functional, but also that makes it very intuitive to use and very clear to use. You don't need an explanation. You don't need to read the manual in order to operate this radio, for example. Why do I mention Dieter Rams here? Because he has 10 principles of design. Okay? So he prefers to go with the 10 principles. But there's one principle, the last one, which I really like, and which works really, really well, in my opinion, for data visualizations. So he talks about good design as being that you can read it, innovative, aesthetic, honest, long lasting, etc. It's part of it is based, of course, on product design, environmentally friendly. You can't really translate that to data visualizations, but his final principle of good design, the 10th one, is good design is as little design as possible. Or in German, because he is a German, of course, it's famously known as weniger, aber besser. I suppose that as you're studying in Luxembourg, you will be quite familiar with German, probably much more familiar than I am. To weniger, aber besser, so less, but better. And this applies to design, although in design you can discuss a little about it. Sometimes superfluous details or extra decorations can make something nicer. But in data visualization, usually the things that we are trying to talk about, that we're trying to communicate, are already complex enough by themselves. So we should make them as simple as possible to also make them as clear as possible to our audience. And I have one to wrap up these design principles. This is, for example, an example from The Guardian, one of the leading newspapers when it comes to data visualization efforts. And they are also a big fan of simplicity, especially for in a newspaper. There's a lot of things to read in a newspaper, so people don't have a lot of time. So if The Guardian is creating data visuals, they want them to be interpreted as quickly as possible. So for example, here, they want to compare how many male people are arrested, how many female people are arrested. Don't exactly know about what topic we're talking here about, but immediately the message, the story is clear and the comparison is clear, and it's very simple. There's no legend needed. There's no more explanation needed. It's just dots on a piece of paper or dots on a screen, and we know what's going on. So this is, for me, it's a great application of the weniger aber besser mindset. And it's something I try to do in my data visualizations as well. And if you are creating a data visualization and maybe during the homework assignment or during the upcoming sessions and you're struggling with something, then usually the most common reason when I see people struggling with data visualization is because they're trying to tell too much. They're trying to put too much information into one visual. And then my advice is just make it simpler. Maybe create 2 simple data visualizations or 3 simple data visualizations rather than trying to press everything into one complex data visualization. But then, because then it will be difficult to create, it will be difficult to interpret, it will be difficult to explain. Weniger, aber besser. That's the design principles. There are also storytelling principles. Let me first have a drink of water. So the storytelling principles, if we want to make sure that our data visualization doesn't just show the data, but also shows the story behind the data, we will need to apply some communication principles and, for example, telling a story. What's it about? There's much more to storytelling than what I'm going to cover here. We'll just highlight a very tiny part of storytelling theory, but the part I think is most important for creating a data visualization. So just like any kind of good communication, if you want to tell a story with your data visualization, you have to take a step back and think about what your goals are, think about who your audience is, and think about the message that you are trying to share. And especially put yourself in the shoes of your audience. What do they want to know? Because like in any case of communications, it's about them, it's about your audience, it's not about you. If you don't get your message across to your audience, it's your problem and it's not their problem. So you have to make sure that the message that you're trying to get across is adapted to them. You don't have to force your own message onto them if it doesn't apply to them or if it doesn't interest them. If you're trying to identify a good story in your data, if you have a lot of data but you're not sure what the interesting story is or what the interesting message is, there are a few approaches to find something which is interesting or which could be a nice message to share. Hot topics, for example, is one of my favorite ways. It's a little bit marketing tactically. Wow. But hot topics, it will always be easier to talk to someone about something or to share something with someone if it's a hot ongoing topic. For example, now, this week, I have a background in physics, as I told you, so I'm very interested in, for example, the Nobel Prizes and the Nobel Prize in physics. So each year I try to make data visuals about the Nobel Prize in physics. And actually, this week is the announcement of the new Nobel Prize laureates in the different categories in medicine, in physics, in chemistry, etc. So if I want to share my data visuals about the Nobel Prize, this week is the week to do it. I could also share them in February or in March, but then nobody would be interested in it because it's a hot topic now, and it will be a hot topic maybe at the start of December when they are actually awarded. But in the rest of the year, nobody is really interested in it. If you want to make a data visualization about the Tour de France, you have to make it at the moment that the Tour de France is going on or is about to start or has just finished. Then people will be interested in it and not in the rest of the year. And if there is something in your research that you want to communicate about, it's often very handy if you have some data visuals or some concepts for data visuals in your drawer somewhere. And then when something happens in your field, for example, if you're working on genomics or on CRISPR, for example. And then today was announced that two women who have worked on CRISPR-Cas have won the Nobel Prize in chemistry, and you have something lying in your drawer about CRISPR-Cas, then maybe today is the day to share that data visual that you had in your drawer, and not on another time, or you can share it multiple times, of course, but if you talk about hot topics, it will immediately catch more attention of your audience than it would do if you would talk about it on any other time of the year. And of course, that's why it's in bold. If there are things you care about, and I'm sure that it will be the case with your research, it will always be easier to convey your message and to show your passion about it. So if you create data visuals about your research, where you know a lot about and where you care about, will always automatically have more impact than other data visuals. If this, yeah, I should maybe skip a little bit because it all amounts to the same thing, and what's in bold on the end is the most important thing, and I already mentioned it a little bit. Limit yourself. If you're struggling with coming up with a good data visual or with a good message or with a good story, then it's possibly because you're trying to say too much at the same time. I will give an example right away. So let's go back to the Nobel Prize. If you don't know these men, these are the three men who won the Nobel Prize in physics last year. Yeah, I'm a little bit struggling with news updates currently because the Nobel Prize for 2020 was announced yesterday, but I didn't have time to include it in my presentation yet. But these are the three men who won the Nobel Prize for physics in 2019. Wait a minute, let me check their names. Michel Mayer, I think, yeah, Didier Queloz and James Peebles. They won the Nobel Prize in physics, and what always strikes me when these laureates are announced, it's almost always it's white old men winning the Nobel Prize in physics. So I was interested in maybe I can dive into the data of the Nobel Prize laureates and see if this is really true what I think. Are it indeed always old people, or are it indeed always white people, and are they always men? That was something that I wanted to know. So I looked up the data for the Nobel Prize winners. This is something that will come back later in the sessions again, because I think it's an interesting data set. And I tried to look at a few things just in Excel, create some visuals. For example, the average age of laureates. Is it indeed true that it are always old men? And there you can see something interesting that actually before World War II, so between 1900 and 1940, for example, people who were winning the Nobel Prize were actually pretty young. They were between 40 and 50 years old. But since the Second World War, the average age has been increasing and increasing. And nowadays, if you want to win the Nobel Prize in physics, you apparently at least have to wait until you are, until you are retired. So things have definitely changed somewhere there, somewhere around the Second World War. That's one thing that's interesting for me in that data. The number of laureates has also increased a little bit. So where it used to be just one laureate, now it's always like 2 or 3 people winning together, but not very significantly. In my opinion, that's not really a very interesting thing to create a data visualization about. But another striking thing to me was the gender balance. It has changed now, of course. I have again been fucked a little bit by the latest news, because these are the numbers for last year. So up until 2019, 210 men had won the Nobel Prize in physics and only 3 women. So that's a striking difference that I wanted to visualize, and I made a visualization about it. Let me go immediately to this one, showing that I wanted to make a visual that really tells, that doesn't just show who won. That was maybe my first approach. This is an overview of everyone who won, but it didn't really tell a story. This just shows the data and doesn't really tell the story about this difference in this gender imbalance that I wanted to show. So I created a new version of the visual. And here, by making everything the same color and just changing the color for these three women who had won the Nobel Prize in Physics, I created emphasis. So one of the design principles, I created emphasis on the fact that only three women won the Nobel Prize ever compared to 210 men. So now, yeah, so luckily yesterday it was announced and another woman won the Nobel Prize in Physics. Um, so Andrea, what's her name? I forgot. Sorry. Um, so it has changed a little bit since yesterday. So I'll have to update my figure, but just to show you how I went about finding a story inside the data, discarding some things that weren't, I think, really newsworthy or really interesting to share, identifying messages which were interesting to me or surprising to me, and then creating a visual that doesn't just show the data, but also shows a little bit the story behind it. Oh, I did include it in my presentation. Sorry, yeah, this is the latest version from yesterday. So Andrea Ghez has won the Nobel Prize in Physics yesterday, and she has become the fourth woman to win it. So that's what some people call we want to share with our audience, not just the what. If you're talking about your research, you don't just want to share the what. You don't want to tell, I'm doing research on this or this tumor. You want to share the so what. You want to share, I'm doing this because it will impact this in that way, etc. So don't share the what if you're talking or if you're creating a data visual. Make sure that your visual shows the so what. Or it brings me back to the one sentence that I want to make this session about. A good chart doesn't just show the data, but a really great chart tells a story. I have a concrete example, for example. I have an example of a visual. So the visual on the left, to me, this just shows the what. It shows data on, this is in the United States, a consumption of different kinds of meat, so pork, beef, and chicken. And this shows, how it has evolved over the last few decades. It shows the data and it's absolutely correct. But it's not necessarily very interesting. It doesn't tell a story and it doesn't show us a so what. So people have to look at it quite some time and they have to make up their own mind and build their own story around it. And that's maybe not what we want as researchers when we're creating a visual. We want to maybe guide our audience a little bit towards the right story. So this is a recreation of the same data, but in a new visual. And here, by adding a little bit of color, for example, by making two of the lines gray, the beef and the pork line gray, and by coloring the line of the chicken, which has been increasing, so the consumption of chicken meat has been increasing since 1965, almost continuously. Now there is a story. Simply by changing the color, we went from a what to a so what. And also notice that it's this storytelling is increased further by also changing the title. So the title on the left is a little bit, it's a boring, just descriptive title. So it's the US per capita consumption of poultry and livestock. Okay, yeah, what? But the title on the right is really telling us a story. It's really telling us so what? Americans are eating more chicken than ever before. So this title has a meaning and this title tells a story. So changing the title and changing the color, these two things here, turned the message from a what into a so what. Okay, I will put you back to work now for 10 minutes. So I hope that you have some pen and paper with you. I want you to spend 10 minutes thinking about your own research and try to identify some key messages about your research. And the basic rule is please try to create messages, just a short, memorable sentence try to create messages which are not just what, but which are so what. So that there's a meaning, there's a story behind the message. It's not just a data. It's a conclusion. It's a story. If you're struggling with this, then always remember weniger aber besser. Just then make it simpler. We are not familiar with each other's research, so don't worry. Make it simpler. Make sure that all of us will understand it. Don't worry if it's better if it's too simple than if it's too complicated. So and then it would be great if at the end of the 10 minutes you can share these key messages about your research with each other using the chat, and we will have a short look at them together. So let's see each other again in 10 minutes at 16:40, and good luck with this small exercise. Okay, we're back. Thanks all for the great messages. I have been reading along and really impressed because I really like that they are showing a so what and not just a what. So I will read some aloud. It's actually possible to eavesdrop a mobile device communicating through 5G. That's a little bit worrying, but that's good because it immediately triggers us to want to know more about it. If you learn how to tell cancer cells from healthy ones, you can create the perfect chemotherapy. It is possible to use deep learning to process data streams. We help AI help us live longer, healthier lives. Different people create data differently. Cooperation through data integration. Only integration of multiple omics levels will allow understanding gut microbiome biology. I'm not entirely sure what omics levels is, but that's maybe my fault. Computer-assisted reading of Aboriginal Australian life writing and its language analysis is an alternative window into the history of the people, and discovering microglia's role in Alzheimer's disease may help millions of people. Wow. Okay, thanks. I think we are ready for the final part of this first session. So let me go back to the presentation. Okay, so we will wrap up um, this first session with some communication principles. So we already had some basic design principles. We already have some very basic storytelling principles, and now let's discuss some communication principles. So if you have some experience already with scientific communication, maybe in other ways, poster presentations, writing articles, writing for a broad public, then probably you already know a lot of these principles, but it's a good reminder to repeat them and see how we can apply them to data visualization. So let's get back to what Dieter Raam said about design in general and product design, but what also applies to data visualization. So weniger aber besser. Let's make it as simple as possible, as easy as possible for the reader, for the viewer to understand. How can we translate it to communication, or how can we translate it to data communication or data visual communication? Um, I like the approach. You're scientists and engineers, so you will understand what I mean. If we are trying to communicate with our audience, it's best if we improve the signal to noise ratio. So we want maximum signal. Signal in this case is the message that we're trying to convey to our audience. And we want minimal noise. And noise is everything which can distract our audience from receiving our message. A concrete example, for example, during a presentation. This is Steve Jobs announcing the first iPhone, or maybe a new iPhone, not entirely sure if it's the first iPhone or not, but he's presenting the iPhone, and in giving this presentation, and it's something typically for Apple and all the other large companies, if they're giving a presentation, this is completely different from how your typical scientific presentation goes. I think we can all agree about that. But here they do everything to minimize the noise for the public. So, for example, Steve Jobs is not standing behind his desk. Maybe if you go to a scientific conference, you will see the presenter standing behind the desk and giving the presentation. But in that way, the desk is blocking part of your view. You cannot see the presenter because the desk is standing in front of him. That's a sort of noise because it's making it more difficult for the audience to see the body language of the speaker, to see the speaker himself, to see how he moves, how he behaves. So this desk is in fact a bit of noise, blocking it, making it more difficult for the audience to receive the message. And so Steve Jobs, if he gave a presentation, and you will also see it with very experienced presenters, they will never stand behind the desk. They will just simply walk on stage and start giving their presentation because it eliminates already part of the noise. The lights in the room are dimmed. The background of this auditorium where he's giving his presentation is completely dark. Also, to minimize the noise, the possible noise during his presentation, so that all the attention goes to him and to what's on the screen. And then on the screen, it's not a typical slide like you would see in a scientific presentation with a lot of title and logos and data and visuals and bullet points and text and whatever. No, it's simply an image of the iPhone and the one word that he wants to talk about, GPS. So this iPhone has GPS. The signal here, the message is made so incredibly big, and all the noise is removed or is reduced to a minimum. All of this is to improve or to maximize the signal to noise ratio in the communication, to make sure that the message here in this case is going to the audience as good as possible. This is for oral communication, for oral presentations. We can do exactly the same for data visualizations, for visual communication. This is what one of the most famous data visualizers in history, Edward Tufte, he's still alive, by the way, but he wrote what can be called the Bible of data visualization. The visual display of quantitative information is the title of the book. And he calls this, he doesn't talk about signal to noise ratio, but it's basically the same thing. He calls it data ink ratio, because we want to maximize, if we're creating a data visual, we want to maximize the data, and or the ink should go maximally to data, to show you data and information, and it should not go to showing you noise. For example, what could be noise? Noise could be like in this figure we have on the left. There's a figure with a lot of noise, so a low data ink ratio. We have a lot of grid lines. We have a colored background, and we have axes, and they're all distracting us from actually seeing the data. So a lot of ink is going to the background and to these grid lines and to these axis lines, which is completely superfluous. Because if we look to the figure on the right, this is a figure which shows exactly the same data and exactly the same information, but a lot less ink is going to these noisy things like grid lines and background. And you can, if you compare both visuals, then you see that it's actually much easier to read and much faster to interpret the visual on the right compared to the visual on the left, because the one on the right has a high data ink ratio or a high signal to noise ratio, and the one on the left has a low data ink ratio or a low signal to noise ratio. And this is another design or another example by Jean-Luc Dumont. Jean-Luc Dumont is an expert in science communication, and he gives a lot of workshops and courses for PhD students. So if you ever have the opportunity to attend a talk of him or to follow a course by him, definitely do so, because he was one of the first ones that I followed a course from when I was doing my PhD, and it really opened my eyes, transformed the way I communicated about my research, and it actually brought me on this career path as well that I'm doing now. So I cannot underestimate how important Jean-Luc Dumont has been in my research career, and I think also in the careers of many other people. And he's talking about exactly these kinds of things. How can we minimize noise, and how can we maximize the signal in everything? So he's going from oral presentations, posters, articles, and also data visuals. So here again on the left, you have a lot of noise with grid lines, which with a legend which is too large and a little bit superfluous. Axis labels, axis ticks, tick labels, which are all unnecessary, because if you look at the visual on the right, you have much less of this noise, and it's much easier to interpret. Notice that it's not only about taking away things, because on the visual on the right, he has also added a little bit of color, and he has also a little bit of arrows and annotations, like the little arrows in the middle. showing the width of the peak being 630 megahertz. These are actually things that he added. So it's not always about taking away. It's also sometimes about adding little things to make it easier for people to understand the data visual. That's the basics. If we want to create a data visual which is simple, it's just taking away things that could block our audience from not understanding our visual. So if maximizing the signal to noise ratio is the first principle of good communication, then thinking about your audience is the second principle of communication. Why your audience is important is I have again included a picture of myself. Sorry about that, but this picture always reminds me of my most challenging presentation ever. This was, I think, shortly after defending my PhD. And I had to give a presentation to a pretty large audience, and it was a very, very tough audience. They were listening from the beginning to the end, but they had many questions, very difficult questions that I was really struggling to explain very well what I was doing in my research. I think the next picture is a picture of the actual audience. So the audience in this case, this was part of, I don't know if it exists in Luxembourg, but in Belgium it's called the Battle of the Scientists, or in Dutch, the Wetenschapsbattle. And the goal is PhD students or people who have just finished their PhD are selected to present their research to an audience of children between 6 and 12-year-olds, which is very challenging and very difficult, but also very fun to do. And it forces you to think about what you are doing and what you're trying to say very well. You have to explain it in a very simple way, but your research, but also without oversimplifying it. But like Einstein said, it's a little bit of a cliche, but it's very true. If you cannot explain your research to a child, then you maybe don't understand it well enough yourself. So you have to understand what you're doing very well, first of all, and then you have to make it as simple as possible in trying to explain it to your audience. And we as researchers, we often have the automatic intent to make everything as complex as possible, to show off maybe a little bit how hard we worked and how much we know about this topic. And we want to make it seem a little bit more complex than it actually is. But what's actually more difficult is to make it as simple as possible. That's sometimes more difficult. So adapt to your audience is the second key communication principle for me. Someone who does this very well, it's an example that I will never forget, is in J.K. Rowling, for example. So this is the second book from the series. And what J.K. Rowling typically does is she doesn't want to repeat everything which has been said in the first book, but she also wants to make it possible for her audience who has not read her first book to understand what's going on and to understand what's happening, or to remember what's happening. Maybe it's a long time ago since you read the first book and now you're reading the second book. So what she, for example, will describe is Harry Potter wakes up from a dream, and he touches the scar on his forehead, which is aching and is shaped like a lightning bolt. So in one sentence, she gives you some new information, the fact that his scar is aching, and she also tells a little bit about some previous knowledge from the first book, like that there's a scar and that it's shaped as a lightning bolt. But if you already knew that, then it's maybe irrelevant for you, but then you also have the new information in the sentence. If you didn't know it, then you learn this old information, and then you also get the new information all in one. So in that way, she makes it easy for her audience to understand what's going on. And it doesn't matter if you have read the first book or not. So some questions to ask if you are thinking about your audience. Try to put yourself in the shoes of your audience and think about who is my audience actually, what, and as I said, it's about them. So it's not about you, what you really with all your heart want to share to them. It's actually what they want to know, what they need to know. That's the important thing in communication. And what do they already know? Um, One important thing there to note, I know that I've been talking already a lot and giving you a lot of information and maybe stupid advice, but this for me is very important, or an important thing that I learned. We as scientists, I'm thinking back now to myself when I was a PhD researcher, so I'm trying to put myself in your shoes, but we always have a little bit of an imposter syndrome. I think that's very typical that we believe that everyone around us is much more smarter than us, knows much more about the topic than we do. Um, and this translates that in if when we're writing an article, we are afraid of making it as simple as possible because we think that people will think that we're stupid, or we think that whoever will read this article will be very smart, will know already everything about this, and we want to make sure that we show that we have really done a lot of good new work and important work. Um, while in fact that's not really true. The majority of people who will read your article when you're writing a scientific article are, for example, starting PhD students who, just like you, know maybe still only very little about the subject. So it doesn't matter. It's no, it doesn't hurt to make it a little bit more simpler or to do a little bit more explanation, because of a lot of people who will read it will be maybe starting PhD students, or a lot of people who are reading it will be actually researchers from a related field, but not actually the field that you are in, but they are trying to learn something new about your field, or they are trying to learn how this maybe relates to their field, but they are not very into all this, the little details and nuances of your field of research. So again, it doesn't hurt to give a little bit more explanation and to make it a little bit more, to explain it in a little bit more simpler and more basic way maybe than you would do, because the feeling that we have, this imposter syndrome, that everyone else, and especially everyone who will be reading our article, is much smarter than we are. In practice, this is actually not true. So if you try to put yourself in the shoes of your audience, it's safe to assume that they know a little bit less than you actually think they will know. So it's safe to do a little bit more explanation, or to explain it in a little bit more simple way. And nobody, even if they know more about it, nobody will mind that it's explained in a little bit more clear and a little bit more simple way. It doesn't mean that your research is worth less or that it's less important. It just means that people will understand it better. So that's worth a lot. Because if you don't adapt to your audience enough, then you will get what I dreaded the most while I was doing my PhD, which are poster sessions, where yeah, poster sessions like this are unfortunately very common. Maybe not now during this period, but when we still had physical conferences, then poster sessions like this were very common, where you have hundreds and hundreds of posters. People only have a few hours to walk by all of them. So for each poster, people just have 1 or 2 minutes to look at the poster and to interpret what's going on and to learn about the research. So that's what if you put yourself into the shoes of your audience, people have 2 minutes. So your poster should explain in just 2 minutes what your research is about. But what people do is they put entire articles on it, they put lots of information on it, introduction, materials, methods, results, conclusion, and then a lot of source information and all the names and all the contact details. But that's useless because that's too much information to deal with in just a few minutes. A poster really works if you simplify it, if you strip it to the basics, if you just put your key message on it, like the one sentence key message that we extracted in the previous exercise. That's the key message, the one sentence that we want our audience to remember when they go home. If they go home at night and they talk to their partner and they say, hey, I saw a very interesting poster today and it was about that one sentence that they talk about, that's what should be on your poster. And all the rest of the information, that too much information for people to handle. So, and I see this over and over again in all these poster sessions. And maybe it's me, but I don't think so. But for me, that's an overload of information because everyone is trying to show off and nobody is really thinking about what does my audience actually want to know. And that's the important thing, to make sure that your audience gets something valuable, that they understand it, and then that they remember it. And a final communication principles, because I have 3 communication principles for you, is to use effective redundancy. We already talked a little bit about redundancy. Well, I weaseled it in a little bit in our exercise on the group exercise on the data visuals. But a good communication always gives our audience a little bit of redundancy, so that there will always be noise. If you're giving an oral presentation, or you're giving an online presentation, or a poster presentation, or you're creating a data visual, there will always be some kind of noise which is unavoidable. People will be distracted. For example, if I'm talking to you now, but you are probably sitting at your desk at home and you're maybe distracted by looking out of the window, or you're eating or drinking something, or you're checking your mails. So that's noise that I cannot avoid. But what I can do to fight it is introduce some redundancy. For example, like what I'm doing now, I'm talking about it. I'm talking about redundancy and what effective redundancy is. But at the same time, it's also on the screen, so you can also read it. If you're not really listening to what I'm saying, you can also see on the screen what's actually going on, what I'm talking about. A really common example of redundancy, for example, a great example is a stop sign. Stop sign has a lot of redundancy built in. For example, there's a white line on the ground, on the street, that shows you that you need to stop. If you're driving your car and you see this white line on the street, you know that you have to stop. But maybe it has been snowing or raining and you can't really see this white line on the street. Then you will also see the stop sign, which is next to the road, and it's in bright red, so it will be very easy to spot. But maybe you cannot see the bright red stop sign because, again, it has been snowing or it's covered in mud. But then you still have the shape, the octagonal shape of the stop sign, which is very recognizable. And so even if you can only see the shape, you still know that it's a stop sign and that you should stop. So even if you can't see the line on the street, you can't read the sign, you can't see the color, but then you can still see the shape. So there's a lot of redundancy built in, so that even if something drops along the way or goes lost along the way, you still understand what's going on. And you can do the same if you're creating data visuals or if you're giving an oral presentation. For example, this is a slide from my PhD defense about my glow-in-the-dark materials, and I try to build in some redundancy here. For example, let's look at the bottom. I will not explain in detail what this slide is about, but let's look, for example, at the bottom, and there you see there's a little table of contents actually on the bottom. So we had the first part of the presentation about the mechanism of glow-in-the-dark materials, then something about trap depth, and now we are in the third part on nitridosilicates. And by coloring this third part, the audience immediately knows, even if they, I don't know, slept for 20 minutes and they now wake up and they see this slide, then they see immediately, oh, we're in the third and final part of the presentation. That's nice. So that's a bit of redundancy built in for the audience. Also, this visual shows, and I will probably be talking about this visual during my presentation, that the material which I made, so the last one, the calcium nitridosilicate, is much more stable compared to the other persistent phosphors. This is something that you can see in the visual. I also highlighted it with the color and shown it with the arrows, but I've also added some additional redundancy by also making sure that the title is very descriptive, is giving this message again. It's not just a descriptive title, it's a title that really conveys the message. So the message that I'm trying to show is both in the title and in the visual and in the choice of the colors. And then we still have where we are in the presentation at the bottom. So there's a lot of redundancy built into this presentation. Let me see. Okay, I still have a few more minutes. So this is my final example for today. This is a data visual which I created a few months ago, and it shows, it's maybe a little bit difficult. This is the first version, and I'm also not very happy with the first version, but I will soon show you the second version. This is the first version of the data visual, and what it shows is actually the distribution in the world of wealth. That's shown in yellow, so where wealth is concentrated, and then you can see, because there's a lot of we're looking at the longitudinal distribution. So there's a lot of wealth located in the West, in the Americas, and especially in North America. That's indicated by the large yellow area there. And the yellow area in Europe, Africa, and Asia is much smaller. And that's compared to the distribution of population, which is the blue area. So the blue area, there's a little bit of population in the Americas and also in Europe and Africa, but there's a lot of population in Asia, especially around India and around China and Southeast Asia. So this graph shows a little bit the imbalance between where population is distributed in the world and where wealth is distributed in the world. But it's all put on it's looked at in a longitudinal way. So you need to understand this longitudinal binning to really understand what's going on in the charts. And that's missing a little bit in this first version. And I noticed it when I put it on Reddit. There's a great subreddit called Data is Beautiful. I put it on there to gather some feedback. And the feedback was very friendly on Reddit, going from this is extremely useless visualization to what should be, I think, the title of my next presentation. It should be, this presentation is fucking terrible. Sorry for my language, but that was the feedback which I received. But luckily, this is, of course, a little bit the extreme cases, but I also got some really great feedback. And what I noticed was that there was not enough redundancy built in the visual. It was not very clear that we were dealing with longitudinal distribution here. And I wanted to add some redundancy to make it really, really clear to people that we were talking about longitudinal distributions. So what I did was, this is comparison between the original version on the left and the new version on the right. And in the new version, first of all, I added some words to the annotation. So now it says explicitly longitudinal distribution. And I also added explicitly some grid lines indicating these degrees of longitude, so going from 150 degrees west to 150 degrees or 180 degrees east. So by indicating these degrees, grid lines gives a little bit even more redundancy to show people what's actually going on in this graph. And then finally, I removed the mirroring, which I did in the original version, which was distracting people a little bit. So now the wealth distribution is on top of the line and the population distribution is on the bottom of the line, because this mirroring was confusing people. So it was not only, I made it simpler not only by adding some information, but also by removing some superfluous design choices, which made it gave people a difficult time. So for excellent communication, if you want, and this applies both to oral, written, or visual communication, improve the signal to noise ratio, make sure that you adapt to your audience, because if you don't adapt to your audience, it's all in vain what you're trying to do, and build in effective redundancy so that even if there is noise, you can fight it you can make sure that your message will reach your audience in the end. And then we can and we will go into detail in the next session how we can do that. We can not just make good charts that show the data, but we can create charts that tell stories and stories that will reach our audience. So that's it for the first session of the 4. I will leave you in a few minutes, but I will already introduce part of the homework assignment. So you can already do part of the homework now if you want to do, because it ties back immediately to what we have seen today. So I have included links to 3 data sets. So I will also upload the slides to Moodle immediately after the presentation, but remember that you can also download the presentation here at this link. So barion.be/datavis resources. It's called datavis-resources. I will also put it on Moodle immediately after the presentation. There are 3 interesting data sets which I have found, and I have added links to them. And you can choose one that interests you most. So there's a data set about Titanic survivors. So passengers of the Titanic, some survived, some didn't, and you get information about their gender, about the class they were traveling in, their age, etc. There are survey results from a survey that Stack Overflow conducted with a lot of developers in 2017. And there's the data set which I have already shown part of Nobel Prize winners between 1900 and 2020 in different categories. And then again, you get the name, you get the age, you get the country they were born in, gender, etc., etc. And what I would ask you to do is to take 30 or 60 minutes, have yourself a cup of coffee or another drink, sit down with this data set, load it up in Excel, and try to familiarize yourself with it. What columns do we have? What information do we have? Try to make some basic graphs, maybe in Excel or in the software that you're most familiar with. And try to already take a sheet of paper and write down 1 or more key messages that you can derive from it. For example, if you're looking at the Titanic data set, maybe there's a distinction between men on the Titanic and women on the Titanic in their age or in how much they survived, or that could be a key message, for example, for that data set. But don't make it too hard on yourself. If you're struggling, then maybe just make it simpler. Make it a short 1-sentence message that you're trying to extract from the data set of your choice. And don't worry too much about it. We will work further on them in the next sessions and in the next parts of the homework assignments. So that's about it for today. I don't think there's really time for a Q&A, but if you have a pertinent question, make sure to just send me an email or send me a message in another way through Twitter, for example. And we will see each other again on Friday for the next session. I believe it will be at 9 a.m. in the morning. So I will leave you with that. Here in Ghent, the sun is shining, I hope as well in Luxembourg or wherever you are, so you can maybe enjoy a very nice evening tonight, and I will see you all again on Friday. Thanks for attending. Thanks for listening to my voice for over 3 hours. My throat is a little bit sore now, but I will have a cup of tea and already looking forward to Friday. Thanks and see you.